Hello, in my last video, I made a prediction as to what Will Duffy and his entourage should see in Antarctica in December. I am, of course, referring to the final experiment that he is conducting. And when I made that video, I started off by creating a 360-degree panoramic view that I would use as a backdrop, as if it was a virtual camera and I was in situ trying to track the sun as it moved over the course of a 24-hour period. And when I made that backdrop, that panoramic view, I took absolutely no care as to the size and the placement of anything. I just wanted something that people could see as the equivalent of terrain going by and see how the sun compared to that particular horizon. In one of the videos that I saw Will Duffy had put out, one of the suggestions he got was to bring a drone along so that he could use it to take a picture of the sun should the sun go behind one of the mountains. And I thought that was a very good point. And I wanted to investigate how different that background that I created should have been and whether or not I should recreate that background to get a little bit more of a realistic animation. So the way that I went about doing it was I went to Google Earth and straight away I just went to Union Glacier Camp. You can see a whole bunch of marks in one direction like this here. That's very likely where they have been camping shortly before this satellite image was taken. And I just went and put myself right there. And then I started to pan around like this here. As you can see from this panoramic view, I went and I found the two highest peaks that should be visible from that camp. Using the elevation that they displayed, I went and found the highest elevation, which would be about there at 1381 meters. And the next peak after that I could find was this one over here, which was at 1900 meters or thereabouts. But it turns out that this one appears higher than this one, at least from the base camp. And so with that, I ended up drawing a measuring line from the camp to that peak over there, which would be this one right over here. So when I look at the properties of this line over here, according to Google Earth, it measures 3.94 miles or 6.34 kilometers. Unfortunately, if I want the heading, I pretty much have to use a new ruler, which I worked out to a heading of 231.81 degrees. The elevation profile at this particular point is 687 meters. So now what I wanted to do is I wanted to find the angle from my horizontal to the peak of this mountain. And according to Google Earth, I am at an elevation of 687 meters. And this peak right here is 1,381 meters. Subtracting 687 meters from 1,381, I'm left with 694 meters of elevation delta, but that would assume a flat Earth, and I wanted to calculate the drop, including Earth curvature. I just plugged the values into Walter Bisland's Earth curve calculator. The distance between the base camp and the peak of that mountain is 6.34 kilometers, which would give me a drop of 3.15457,516 meters. And an alternative way of calculating that, I took the equivalent in miles, squared that, and multiplied that by 8. That gave me a drop of 124.209957,893 inches. Converting that back to centimeters is 315.49329 centimeters. Converting that back to meters, 3.15 meters, which is this value here. If I subtract 3.15 meters from the delta, that would mean that The peak of that mountain should be the equivalent of 691 meters above my current position with a distance of 6.34 kilometers. I do an arctan of those two numbers and I get a value of 6.22 degrees. So roughly speaking, this should be 6.22 degrees. And how does that compare to what I created? I took one of the images that I had generated to create that animation. This one was at an azimuth reading of 231.86 degrees. And according to this, the sun should be at an altitude of 17.27 degrees above horizontal. At local solar midnight, the sun still had an altitude of 13.15 degrees, which would represent a good 2 times higher than the tallest visible peak from that base camp. So with all that reckless abandon and not having any care as to coming up with any sort of accuracy, it turns out that I was actually pretty close, and that the sun really should remain quite high relative to the surrounding horizon. And after a bit more thought, I had a few more ideas that could possibly make this expedition a little bit more rigorous, robust, and informative, perhaps. I think it was already suggested by somebody else, is that Will Duffy and or the gang should bring along a 180 or possibly a 360-degree view camera. Assuming that the weather conditions are not going to kill the camera, it would really be interesting to tape the camera to a pole that would remain in place for a full 24 hours. I think it would really be interesting if they could somehow put together some sort of contraption that would provide a heated enclosure for that, along with an extra long battery pack that would allow it to record a full 24 hours. And if they could do that, it would really be nice to upload the entire video to YouTube as a 360-degree view video so that the entire internet afterwards could look in all sorts of different directions as if they were really there. A second idea that I had was using an app on a cell phone, for example, like a theodolite app. It would be nice to take elevation angle readings of the sun at regular intervals and comparing it against various tools like timeanddate.com, SunCalc, Stellarium, etc. The next idea that I had that could make things more useful is to bring along a whole bunch of utility marking flags, the same kind that the utilities stick in lawns when they mark out where a buried hydro line, for example, is, or a natural gas line or similar. And with different colored flags, I'd recommend creating a giant 4 or possibly 8 direction cardinal compass right in the snow for the duration of the trip. That way there, every time that you take a photo or take a video, if you keep that in shot, it'll give everybody a reference marker as to the direction that you're facing. So that's all that I have at the moment. If you like the video, you know what to do. Thank you very much. And with that, I'm going to see you in another video soon enough. So bye for now.